Bismillahirrahmanirrahim. In our today's lecture, we will discuss about numericals of chapter number 4. Numerical number 4.6. If an object of mass 2 kg is thrown up from the ground, reaching the height of 5 meter and falls back to the earth. एक ऑब्जेक्ट जिसका मास 2 किलोग्राम है उसे ग्राउंड से ऊपर की तरफ फेंका गया और वो 5 मीटर की हाइट तक जाने के बाद जमीन की तरफ वापस आना शुरू हो गया और इस केस में हम लोगों ने एयर डिस्टेंस को निगलेक्ट किया हुआ है. सो द गिवन डाटा इज the mass of the object that is represented by m is equal to 2 kilogram and height of the object that is reached by the object is 5 meter. Calculate. Number 1, the work done by gravity when the object reaches at 5 meter height. We have to find the work done in first part. So W G is equal to question mark, that is work done by gravity, and in second part work done by gravity when the object come back to the earth. Again we have to find the work done by gravity. So it is represented by Wg prime is equal to question mark जब ऑब्जेक्ट अर्थ की तरफ वापस आ रहा होगा. एंड नंबर 3 पार्ट द टोटल वर्क डन बाय द ग्रेविटी इन अपवर्ड एंड डाउनवर्ड मोशन. हम लोगों ने टोटल वर्क डन फाइंड करना है अपवर्ड और डाउनवर्ड मोशन में. सो थर्ड पार्ट इज द वर्क डन total is equal to question mark. Also mention the physical significance of the result. We have to mention the significance. So significance is equal to question mark. Solution. Number 1 part, as we know that the object is moving upward and the force of gravity acting downward, so the work done by gravity is equal to minus mgh. Negative sign indicates the opposite direction of displacement and force of gravity. By putting values minus 2 into 9.8 into 5, it is equal to 98 minus 98 joule. It represents the work done by gravity when the object is at the height of 5 meter. In second part, we have to find the work done by gravity when the object falling downward. So Wg prime is equal to mgh positive में, because in this case force of gravity and displacement are in the same direction. By putting the values 2 into 9.8 into 5 is equal to 98 joule. Now in third part we find the total work done. So part number 3, W total is equal to Wg plus Wg prime. By putting the values of Wg and Wg prime, minus 98 plus 98 is equal to 0 joule. So the total work done when the object reaches to the ground is equal to 0 joule. And also we state the physical significance. So significance of this result is that the force of gravity is conservative because the total work in complete round trip is equal to 0. Numerical number 4.7. An electrical motor of 1 horsepower is used to run a water pump. The given data is the power of motor is 1 HP, means 1 horsepower, which is equal to 746 watt, because 1 horsepower is equal to 746 watt. Water pump takes 15 minutes to fill the tank of 400 liter at height of 10 meter. The time taken by the pump to fill the tank is 15 minutes, which is converted into seconds by multiplying it by 60. So time is equal to 900 seconds, and volume of the water is 400 liters. Also, we know that 1 liter is equal to 1 kilogram. So mass is equal to 400 kilogram. That is the mass of water. Further, height that is given, h is equal to 10 meter. We have to find in part A actual input work done by the electrical motor to fill the tank. Input work done is represented by W1 is equal to question mark, and in part B actual output work done. So W2 is equal to question mark. Solution: the input work done by the electrical motor can be determined by using the formula of power, that is power is equal to work done divided by time. Input work is represented by W1, so W1 is equal to power multiplied by time. By putting values, power is equal to 746 into time is equal to 900 seconds. After solving it, it is equal to W1 is equal to 671.4 joule. We find output work done, that is determined by W is equal to mgh, because the water is taken at some height. By putting the values, m is equal to 400, g is 9.8, and h is, that is given in data, 10 meter. It is equals to W is equal to 39200 joule, or W is equal to 39.2 kilojoule. This is the output work done, that is represented by W2. So we use W2 in this formula. Numerical number 4.8. A passenger just arrived at the airport and dragging his suitcase to luggage check in the desk. एक पैसेंजर जो कि एयरपोर्ट पे अभी पहुंचा और उसने अपने सूटकेस को लगेज चेक डेस्क के ऊपर लेके जाना है, जहां पर वो अपने सामान वगैरह को चेक करवाते हैं. He pulls the strap with the force of 200 न्यूटन. उसने वो बैग के अपने स्ट्रैप को पुल किया, खींच के वो लेके जा रहा है 200 न्यूटन की फोर्स लगा के एट एन एंगल ऑफ 45 डिग्री टू द फ्लोर टू डिस्प्लेस इट 50 मीटर टू द डेस्क. तो डेस्क तक उसने जब अपने लगेज को लेके गया, उसने 50 मीटर का डिस्टेंस कवर किया, 45 डिग्री का एंगल था उसका, और 200 न्यूटन की फोर्स लगा रहा था. सो गिवन डाटा इज F is equal to 200 न्यूटन, एंगल थीटा इज इक्वल टू 45 डिग्री, and displacement covered by the passenger is 50 meter. Determine the value of work done by him on the suitcase. उसने suitcase पे जितना भी work done किया उसकी value determine करनी है. So we have to find the work done. W is equal to question mark. Solution: as we know that the formula of work done is W is equal to FD cos theta. By putting values in this formula, F is 200, D is 50 meter, and cos theta is equal to 45 degree. After solving it, it is equal to W is equal to 7070 joule, which is equals to 7.0 kilojoule. This is the value of work done by him to take his bag to the luggage check desk. Numerical number 4.9. A 1200 kilogram car is running at a speed of 40 km per hour. एक कार है जिसका mass है 1200. So given data is mass of the car is 1200 kilogram, running at a speed of 40 km per hour. So velocity of the car is 40 kilometer per hour, which is converted into meter per second by multiplying it by 1000 and divided by 3600. It is equals to 11.11 meter per second. How much power will be expended by it to accelerate at 2 मीटर पर सेकेंड? अगर हम लोगों ने उस कार को मूव करवाना है 2 मीटर पर सेकेंड स्केयर के एक्सेलरेशन से, तो कितनी पावर उस कार को देनी पड़ेगी? सो P is equal to question mark. The formula of power is equal to work over time, and work is equal to F dot D divided by T, and here displacement over time is equal to velocity. So power is equal to F into V. According to Newton's second law of motion, F is equal to ma. By putting the values, P is equal to MAV. Mass of the car is 1200, acceleration is 2, and velocity is 11.11. After solving it, it becomes equal to 26,664 watt, which can be written as P is equal to 26.66 kilowatt. Numerical number 4.10. A 200-gram apple is lifted to 10 meter and then dropped. The given data is, एक एप्पल है जिसका mass है 200 ग्राम. So mass of the apple is 200 ग्राम, lifted to 10 meter and then dropped. उसे 10 मीटर की हाइट तक लेकर जाया गया और देन उसे ड्रॉप कर दिया गया. What is the velocity when it hits the ground? उसकी velocity क्या होगी जब वो जमीन को टकराएगा? So V is equal to question mark. Assume that 75% of work is in lifting the apple is transferred to kinetic energy. मीन्स हमारे पास जो वर्क डन उसे करवाया गया उसे लिफ्ट करवाने में उसका 75% हिस्सा उन्होंने अज्यूम किया कि वो काइनेटिक एनर्जी में कन्वर्ट होगा बाय द टाइम इट हिट्स द ग्राउंड, उस टाइम पर जब वो जमीन को टकरा रहा होगा. तो ये हमें एक गिवन कंडीशन दे दी कि हमारे पास जो वर्क डन है, वर्क कन्वर्टेड इनटू, वर्क मीन्स इट्स पोटेंशियल एनर्जी converted into kinetic energy at the time of it hits the ground is equal to 75%, which is equal to 0.75. Solution: 75% of potential energy is converted into kinetic energy at the time it hits the ground. So kinetic energy is equal to 75% of potential energy, and we know that 75% of potential energy means that 0.75 into potential energy, and the formula of potential energy is mgh. The mass is 200 gram, which is converted into kilogram, so it is equal to 0.2 kilogram. By putting the values in this formula, it is equal to 0.75 into 0.2 into 9.8 into 10. It is equals to 14.7 joule. So this is the value of kinetic energy. Now we find velocity by using formula of kinetic energy. Kinetic energy is equal to 1 by 2 mv square. Solving it for V, so V is equal to square root 2 into kinetic energy divided by m. By putting values, V is equal to square root 2 into kinetic energy is equal to 14.7, and mass of the apple is 0.2. It is equals to 12.1 meter per second. This is the velocity of apple when the apple hits the ground.